Alrighty, so for this question, driving around the corner, we've got the car that is going to be moving along its travel of radius around this way. So we've got our normal forces that is going to be acting in the system. So we're going to have our gravitational force pulling it down and a normal force pointing out, mainly because it's not pushing into the ground. However, in this question, we have also got friction. Now, friction, if we think about this, the car is actually going to want to continue in a straight line and it's going to travel out of the circle. So that means that our friction is going to oppose that change. So therefore, it's going to try and keep it in the circle. The force of friction is also always parallel to the surface, and our surface is at an angle of theta. So therefore, our friction is going to be pointing down here. Our two angles in this situation is going to be from the vertical there and from our horizontal. And we're going to end up with our angle of theta here and an angle of theta there. Now we're going to solve these in our normal sort of way. We're going to sum the forces in both the x and the y direction. So we say the sum of the forces in the y. It's not going to move up or down the circle, so therefore this is going to be equal to 0. And then we add our forces in the vertical positive first, which is going to be Fn, and it's going to be the vertical component of that, so it's this part here, which is going to be our cosine of theta. So cosine of theta. Then we look at the components that are below the line. So these ones here, we have a component of the friction and the gravitational force pulling it down. So we're going to say minus Fg, and we're also going to say minus our force of friction, and it is the sine component of that. Next, we're going to substitute in our values for the force of friction. So we're going to still say this is equal to 0. So we're going to have Fn cos theta minus Fg minus our mu Fn sine theta. Now I'm going to rearrange this equation and by bringing Fg to the left-hand side. So I'm going to end up with all of my normal forces on one side and all of my force of gravity on the other. Now I'm going to factor out my force of the normal. Because I know what I need to do in this situation, I am going to solve this for the force of the normal. So I'm going to divide both sides through by cos theta minus mu sine theta. So I get Fn is then going to be equal to Fg divided by my cosine theta minus our mu sine theta. And that's all that I can do now for the sum of the forces in the y. The sum of forces on the x, though, is going to be our uniform circular motion. So that's going to be equal to our mv squared on r. There are two forces pointing in towards the center. We have the horizontal component of the normal force as well as the same component of the frictional force. So we end up with Fn sine theta plus our force of friction, but this is our cosine of theta. Again, I'm going to solve my force of friction in terms of the normal force. So I then get Fn sine theta plus mu Fn cos theta. Factoring out my Fn gets me Fn outside of sine theta plus mu cos theta. I now have a value though for Fn from my sum of the forces in the y, so I'm going to grab this value down here and plug it into that one up there. So I now get my force due to gravity, and I'm going to have sine theta plus mu cos theta divided by my cos theta minus mu sine theta. From that, I can substitute in my force of gravity, which is mass times gravity. So I get mg sine theta plus mu cos theta divided through by cos theta minus mu sine theta. I have now got a mass on both sides of the equation, so it is going to cancel. And I'm after the velocity, so I need to take the square root and multiply both sides by radius. So that will get me that the velocity is then going to be equal to the square root of rg sine theta plus mu cos theta divided through by cos theta minus mu sine theta. We have all the values for everything here. So now I can just plug those numbers straight into the relationship. So I'm going to get the square root of 60 times by 10. Sine of 30 plus 0.6 times cosine of 30 divided through by cosine of 30 degrees minus our 0.6 times the sine of 30 degrees. This will come out to be 32.8 something or other, but when rounding it will come out to 32.9 meters per second.